$1 million. That is what a software engineer at a top tech company can earn over 4 years. And you know what stands between most developers and that number? 3 letters. DSA. Data Structures and Algorithms. And I know, just hearing those words might make you want to close this tab. But stick with me for 10 minutes, because by the end of this video, you are going to understand exactly what DSA is, why every top company on the planet tests you on it, and you are going to get your very first taste of something called Big O notation. And trust me, it is way less scary than it sounds. Let us go. Okay. So what actually is DSA? Let us break it down. Data structures, that is about how you store and organize information in a computer. Algorithms, that is about the step-by-step instructions you write to solve a problem. Put them together and you get DSA, the science of writing code that does not just work, but works efficiently. Smart code. Fast code. Code that scales. Now here is my favorite analogy for this. Think about language. You can speak without knowing grammar, right? Plenty of people do it every day. You get your point across. It works. But if you want to write a novel, a legal contract, or a speech that moves people, you need grammar. You need structure. You need precision. DSA is the grammar of programming. You can code without it. But to write code that is truly powerful, truly efficient, truly professional, you need it. Full stop. Think about it from a different angle. Imagine you are building a library. A small library, maybe 200 books. You could just pile them on the floor. Someone comes in, they search through every single book, they eventually find what they need. It works. Barely. Now imagine that library has 10 million books. Suddenly, piling them on the floor is a disaster. You need shelves. You need categories. You need an index. You need a system. That is what data structures give you. A system for organizing information so you can find it, use it, and update it fast. Alright. Let us talk about the elephant in the room. Why do Google, Amazon, Meta, Microsoft, why do all these companies make you solve DSA problems in interviews? Is it because your day job is going to be solving puzzle questions on a whiteboard? No. Absolutely not. So why do they do it? Here is the real reason. When a company is hiring, they cannot give you a 6-month project to evaluate you. They have 45 minutes. In those 45 minutes, they need to figure out, can this person think logically? Can this person break down a complex problem? Can this person write clean, efficient solutions under pressure? DSA problems are the filter. They are a compressed, standardized way to test your thinking ability. Not your ability to memorize syntax. Your ability to think. And here is the thing, once you get good at DSA, you do not just pass interviews. You become a genuinely better engineer. You start thinking about efficiency naturally. You start asking the right questions. How fast does this run? How much memory does this use? Is there a smarter way? That mindset, that is what separates good developers from great ones. Okay. Now we get to the fun part. Time complexity and space complexity. 2 terms that sound intimidating but are actually incredibly intuitive once you see them. Time complexity is simply, how long does your code take to run as the input gets bigger? Space complexity is, how much memory does your code use as the input gets bigger? That is it. Those are the definitions. Simple. The key phrase is, as the input gets bigger. We are not measuring time in seconds. We are measuring how the code behaves as things scale up. Because a solution that works fine with 100 items might completely collapse with 1 million items. And that is what we are watching out for. This is where Big O notation comes in. Big O is just a standardized way to describe the time or space complexity of an algorithm. It is a language. A shorthand. When engineers say this runs in Big O of n, they mean the running time grows in proportion to the size of the input. When they say Big O of n squared, the running time grows much, much faster. Let me show you exactly what that means with a real example. Imagine you have a list of names. 1,000 names. And you want to find one specific name, let us say you are looking for Sarah. The simplest approach, and honestly the most obvious one, is to go through the list from the very beginning. Check the first name. Is it Sarah? No. Move on. Check the second name. Is it Sarah? No. Move on. You keep going until you find her. In the worst case, Sarah is the last name on the list, and you checked all 1,000 names. This approach is called a linear search, and it runs in O of n, big O of n. As the list gets bigger, the time grows at the same rate. Double the list, roughly double the time. Clean. Predictable. Now imagine someone wrote a terrible, terrible solution. For each name in the list, they compare it against every other name in the list, just to check for duplicates before searching. So for 1,000 names, they are doing 1,000 times 1,000 comparisons. That is 1 million operations. This is O of n squared. And let me tell you, when your list grows to 10,000 names, you are now doing 100 million operations. At 1 million names? 1 trillion. Your computer will be crying. That is the power of understanding Big O. It lets you look at two solutions and immediately know, before you even run the code, which one will survive in the real world and which one will crumble. Think of it like driving. O of n is like a highway, smooth, consistent. As you travel more distance, time increases steadily. O of n squared is like a city with a traffic jam at every single intersection. The further you go, the exponentially worse it gets. You want the highway. Every single time. Before we wrap up, let us talk about 3 mistakes that almost every beginner makes, and that I want you to avoid from day one. Mistake 1, jumping straight to code. So many beginners open LeetCode, read the problem, and immediately start typing. Stop. Think first. Understand the problem. Sketch the approach. Then code. The thinking is the skill. The code is just the output. Mistake 2, memorizing solutions instead of understanding them. You can memorize 100 DSA answers and still completely freeze in a real interview when the problem is slightly different. Do not memorize. Understand. Ask yourself, why does this solution work? What would break it? Mistake 3, ignoring Big O. You write a solution, it passes, you move on. But was it efficient? Could it have been faster? Beginners skip this question. Strong engineers always ask it. Make it a habit starting today. All right. Let us bring it all home. DSA is the grammar of programming, the foundation that turns a coder into an engineer. Companies test it because it reveals how you think. Time and space complexity tell you how your code behaves at scale. And Big O notation is the language we use to describe that behavior, concisely, clearly, and universally. You do not need to master this overnight. You just need to start. And you just did. Now here is my question for you, and I genuinely want to know. Drop it in the comments right now. What is the one thing about DSA that has always confused or intimidated you the most? Write it down below. Because your answer is going to shape exactly what we cover next in this series. Day 2 is coming, and we are diving into your first real data structure. See you there.